founding fathers of AI, Professor Marvin Minsky, said, "The question is not whether intelligent machines can have emotions, but whether machines can be intelligent without emotions." Today, my talk is going to be centered around the idea of integrating affect recognition into AI systems. Good afternoon, everyone. I'm Jyoti, founder of Kroop AI. Kroop AI is a deep tech startup innovating in the space of generative AI. We enable generation of multilingual video content with only text as input. As for my background, I am a research scientist by training. I did my PhD in affective computing and computer vision from Canberra, designing an algorithm for multimodal depression detection. Later, I worked at several top AI labs, extending my research of emotion understanding onto various mental health disorders. So let's get started with what is affective computing. The term affective computing was coined by Professor Rosalind Picard from MIT Media Lab in late 90s, and it deals with designing and development of systems which are capable of sensing, analyzing, and simulating human affect or emotion. There are two main components of affective computing. First is affective sensing, and then affective response. In affective sensing, first we use different ways of capturing user signals. It could be through RGB camera, or through speech, your prosody, or sentiment analysis done through the text. Once we have these signals captured, then machine learning is employed to make an understanding out of it, to translate user's signal into user's affective state. So once we have affect sensing done, the second component is affect response or affect react. How do we incorporate that information back into the system in order to generate an appropriate response for the user? So I have a video to showcase which is going to demonstrate how affective sensing and reaction takes place. So this video is from a Japanese household where a social robot is interacting with the user. So please take a note how affect sense and affect reaction happens here.
おかえりなさい。今日はいい日でしたか？
うるさい。ほっといて。
ママ。わかりました。いないいないばー笑顔になりましたね。
ありがとう。
So what we saw there, that the social robot can actually sense, using different signals over there, whether from facial expressions or speech, that the user was visibly upset, and then could take that information and generate a response in form of a gesture that elevated the mood of the user. Now let's talk about several different models for affect representation. One of the basic way to represent emotion is categorizing them into basic six emotions. So be it happiness, sadness, fear, disgust, anger, and so on. Another way is to portray emotions in a continuous space. So here what you see is a valence arousal model. Now, valence represents the value of emotion, whether it's positive or negative affect, and arousal signifies the intensity of emotion. So for example, if somebody is feeling very excited, then that goes for high value, high valence, and high arousal. If somebody's in a calm state, then that is still high value, high valence, and low arousal. So similarly, all different emotions can be portrayed on a continuous space model. Another popular school of thought, specifically for facial expression representation, is facial action units. Now, when we make certain facial expression, there are different facial muscles that get activated. Now, these facial muscles, also called action units, and combination of different action units can give us an understanding of what sort of expression is being displayed. For example, when we smile, so there is AU12, which is the lip corner puller that gets activated, and AU6 from the cheek puller. So the combination of that tells the system that it is a smile which is being portrayed. AU12 only will be a Duchenne smile, or sort of a smile that we kind of pass on to strangers walking down the street. So not a real smile, but still sort of a facial muscle that gets activated. Okay, so here I have laid out a pipeline for a very generic affect computing system. And here I'm taking an example of video-based facial expression recognition system. So first, we have the input as different video frames, and then face detection is done to localize the area where the face is in the video. And then some low-level features are computed using pre-trained neural networks. Now, for prediction, based on the complexity of data, the output space, and available computing resources, we can use things like convolutional neural network or a transformer-based architecture. And ultimately, that provides us affective state labels as the output. All right, so now let's talk about where do we see affective computing in action. So I've laid out some examples here, but of course it's not limited to this. So first and foremost, we see the applications in healthcare systems. Now, for stress management, assessment of different mental health disorders, or for patient care, assisting patients in their daily activities, we see the employment of affective computing. In education, affective computing can be used to design adaptive learning modules that will assess the emotion of the student, the affective state and engagement of the student, and can tailor-make the programs based on that. Then in social robots, human-computer interaction, human-robot interaction, affective computing plays a pivotal role because it enables machines and systems to understand and respond to the user effectively such that the engagement or the interaction is much more natural. Then interestingly, in gaming and virtual reality, affective computing can enhance the immersive and personalized experience. In marketing and advertisement, affective computing can be used to do market research on how a particular campaign is being received by the users. And all of that then can enhance the customer experience. All right, so now let's delve a little more deeper into how affective sensing can be used or is currently being used in retail sector. Before we do that, we need to understand the importance of incorporating customer emotions and behavior understanding in the AI systems that we have currently in place. So I remember Bruce mentioning about in the morning that when a guest walk into Target store, how welcome they feel, how warm environment that is there. So let's take that as an example, that customer walks into a retail store and is greeted by a very friendly salesperson who is very quickly able to gauge the customer intent and helps them with their shopping requirement. So that translates to a satisfied and happy customer and business success. Now, similarly, if we want our systems, AI systems, to provide similar sort of assistance to provide a personalized experience for the users, it is important, paramount, to have certain amount of emotion understanding embedded in the systems. Now, let's say the user wasn't happy for some reason, there's dissatisfaction. So, affective computing system can quickly detect the negative emotion or dissatisfaction, and that can help us mitigate the risk and also protect the brand value. Now, once we know the basic emotion and behavior of our customer, we can feed that information to strategize very targeted marketing campaigns. And that can help us in effective product placement, because once we have done targeted marketing, we can still employ affective computing at that stage to understand how the user responded to it, and based on that, effective product placement can take place. And ultimately, that will help us in increasing sales and profitability. Okay. So far we have been talking about how effective computing in retail can be used to analyze customer behavior. But it's not just limited to that. We can use affective computing to also assess the intent of employees and their engagement levels, and identify if they require any sort of assistance for better and effective customer and employee engagement, which will further lead to job satisfaction and employee well-being. Then we can use AI-powered sentiment analysis that will help us to analyze the customer feedback that we see from social media posts or blog posts, and can help us strategize how we can respond to any areas which requires improvement. Effective advertisement is another powerful use of affective computing in retail, because this allows us to understand and gain insights that how a particular campaign is being received by the user, and if there are any sort of adjustment that has to be made. And I have just an interesting demo video to showcase for that particular example. And ultimately, understanding the effect, we can make a dynamic pricing, we can offer personalized sales, personalized offers and discounts that can boost sales. Okay, so this is where I'm going to showcase AI-based engagement and emotion measurement. So there are two users who are watching some content, and what we are looking down plot is their engagement level changing with respect to time, and also their facial action units representing facial expressions and emotions. So once we have collective data from different users, that can really feed into systems and tell us how much engagement that we were able to get from the users. All right, so in this slide, what I want to talk about is confluence of embedding behavior and affect understanding into AI systems, and leveraging generative AI to take customer experience to another level. So first is product explainer videos. We just saw in Anusha's presentation how generative AI is taking things in a different way. Now, with product explainer videos, what we can do is, when a customer's requirements are understood, we can automatically generate videos highlighting the features that would cater more to a particular user. Second, we can create hyper-personalized experiences for customers. Now, the examples could be that if there is a particular sale or product coming, we can send lakhs of messages to different users where a particular brand ambassador or celebrity endorsing that product is reaching out to all these different users by their name. So that is a scale at which generative AI can help us communicate to our users. And lastly, when we talk about our chatbots that we have in place, traditional chatbot system can be replaced by smart interactive virtual assistants who would be able to understand the emotional state of the user and would be able to engage with them more effectively. And next video, I'm going to showcase the example how a smart virtual assistant can assist someone who's there to shop out on a website.
Hi, Jyoti. I am Tina, your smart assistant. It's nice to see you here. There are heaps of deals to pick up from this summer kickoff sale. Is there anything specific I can assist you in shopping today? Alright. There are wide range of options to choose from in outdoor furniture category. Do you have any specific requirements in mind?
Nah, I'm just browsing. Need to change the outdoor furniture. Can you help me with some suggestions?
Oh, certainly. Not a problem, Jyoti. If you are not sure, let me show you our beautifully curated collections for design inspiration. There are varied options to suit your style and needs. There is Earth collection which is more serene and light. Laguna and Tropics offering bright and airy style to your outdoor settings. There are also some other cool styles to browse through. Plus we have some additional items to provide final finishing touches.
Hey Tina, this is amazing. Just what I was looking for. But I've got to go for now, so let's resume it in the evening. Thank you.
No worries, Jyoti. It's my pleasure.
All right. So, what I wanted to highlight here is that this is the future where generative AI will enable a customer to come to your website and have such an interactive experience that they will feel they're actually talking to a real person. But that was not a real person, it was generated by generative AI. So, on that note, I'd like to conclude that integrating empathy in AI has a huge potential and will transform the way we operate today. And it will make sure that there's exceptional customer experience since we'd be able to understand their behavior and intent much better. With that, I'd like to thank you for your time. Namaste.